This topic is integration. So integration is the inverse or reverse process to differentiation, see derivatives. When using integration, you are finding the antiderivative. Antidifferentiation is also known as indefinite integration and is denoted with the integral symbol, which is like this really long kind of S-looking shape thing. If we're looking at an integral, we'll have the integral symbol, we'll have the function we're integrating, and then we'll have dx, so the variable that we're integrating between, and that will equal our integral function. And then we always have to have a plus c with indefinite integration, because think about it, if there was a constant with our original function, if we'd done the derivative of that, that would have disappeared and gone to 0. So we have to do that plus c when we reverse that process, because we don't know if there was a constant or not. Now, integration rules, we've got 4 rules here. So we've got the power rule, the constant multiple rule, sum or difference, and a constant function. So we'll kind of look at these in these next few examples. The main one really that we need to look at is this first one, which is the power rule. So when we're doing the integral of x to the power of 3 or something like that. So let's just go through some and we'll just give them a go. So this first one, we've got the antiderivative of x to the power of 8. So we're going to use that first rule there that I've starred. So if we wanted to write it in integral notation to start with, we can do the integral of x to the power of 8 dx. That's saying we want to find the integral of x to the power of 8 with respect to x. Now the rule for this, really easy. You always do 1 over whatever that power is plus 1. And then we'll have the x, and then we need to do plus 1 to the power. And then we're going to do plus c on the end. So it'll be 1 over 9 x to the power of 9. So we have to add 1, because remember when we do the derivative we minus 1, so when we do the integral we need to add 1. And then we need to make that fraction out the front. Now if we look at b, we don't want it in a fraction if we can, so we're going to rewrite this as the integral of x to the power of negative 3 dx. Now exactly the same idea. 1 over, add 1 to the power, so negative 3 add 1 is negative 2. So it'll be 1 over negative 2 x to the power of minus 2, add 1 to the power as well, and then remember your plus c. For c, we just want to rearrange it so it looks like something we like. So this can be the integral of x. Now remember that's the 5th root, which means it's 1 over 5, so it's going to be x to the power of 3 on 5 dx. Then when we do the integral of this, we're going to have 1 over. Now we want the 3 on 5 plus 1, which will be 8 on 5, times by x to the power of 3 on 5 plus 1, which will be the power of 8 on 5 plus c. Now with this one, we can just make it look a bit nicer and tidy it up, which means that 1 over 8 on 5 would just become 5 on 8. We can flip the fraction, and we'll leave the power as it is, and the plus c. Now, we'll look at the e a bit more later on, but just really quickly, if it's a nice easy one like this one, e to the power of 2x, we can write it in our integral notation. Now with an exponential, you've got to remember that we don't minus 1 from the power. When we do the integral of an exponential, it stays the same. So we just need to put whatever that number in front of the x is on the bottom of the fraction and leave the rest the same. And remember your plus c. So example 2, we're going to find each indefinite integral. So it's just doing just what we did before, but just some different situations. So the first one, just like the first example of the last one, we're going to do 1 over, add 1 to the power, so which will be 8, x, and then add 1 to the power, so 8, and then plus c. b, now 6 is just a constant. Now the thing to note here is it's 6 du, so we've got to bring a u in. Now, if we think about the derivative that just gives us a constant, is say if we had one variable. So this one would just be 6u plus c, because the derivative of 6u is just 6. c, 2x cubed. Now the only issue here is the 2, but that just stays where it is. So we'll have 2 on, add 1 to the power, which is 4, so before go to the bottom there, add 1 to the power, and then plus c, and then we can obviously simplify that to a half x to the power of 4 plus c. Another thing that sometimes people do is that you can, and what you can do is if you wanted to, you can take the constant out the front of the integral, and then do the integral with it there, so we'd have 2 times, and then do 1 on 4 x to the power of 4, and then it simplifies the same anyway, but either option's fine, you just pick whichever suits you best. D, we've got the integral of 4t cubed plus 6t squared plus 3 dt, so our variable is t this time. And now, because they're plussing in the middle, we just do each one separately. So one step you can do, you don't need to, but if you would like to, you can separate this out into 3 separate integrals. But as I said, you don't need to do that step if you don't want to. And then we just do the integral of each. So this will be 4 on 4t to the power of 4 plus 6 on 3t to the power of 3 plus 3t, and then you'll remember your plus c at the end. And then this will be t to the power of 4 plus 2t cubed plus 3t plus c. Part E, same idea. The first thing I will do here is though, I am going to rewrite x to the square root of x to x to the power of a half. And now we do the integral of each separately. So it's a 2, so it'll be 1 on 3 x to the power of 3 plus now a half. So we'll have 1 on a half plus 1 is 3 on 2 x to the power of 3 on 2 plus c, and then simplify. Now remember, when we've got 1 on a fraction on the bottom, we just flip it, so it'll be 2 on 3 x to the power of 3 on 2 plus c. F. Now when we see a single x on the fraction, we have to remember we can't pull this up to the power of -1, because if we were to add 1 we get 0, and then it doesn't work with our integral. So what we need to remember here is that the integral, the derivative that gives us 1 on x is ln. So remember, ln x goes to 1 on x. So if we're doing the integral, we've got to go backwards. 1 on x becomes ln x. So what I'm going to do here is I'm just going to pull this 3 out the front for this one, just so you can see what's happening. Now, integral of 1 on x will just be ln x, reversing the derivative. And then we can just leave the 3 out the front. G, the integral of e to the x on 5. So what I would do here is I would rewrite it as a 5th e to the x, because it just eliminates any issues of fractions. Now the integral of e to the x, same as the derivative, it's the same thing, e to the x and e to the x, which means this just ends up staying the same, we just have to plus c to the end. H, we've got the integral of 2x squared plus 3 all squared. Now what I would do here is, we haven't looked at a rule yet for doing these ones, so because it's only a square bracket, to be honest, the easiest way is probably just to expand the brackets. So it's a perfect square we expand it, we'll get that, and then we can just do each bit separately. So 4x to the power of 4 will become 4 on 5x to the power of 5 plus 12 on 3x to the power of 3 plus 9x plus c, and then simplify. So we'll have 4 on 5x to the power of 5 plus 4x cubed plus 9x plus c. I, we've got the integral of 4x squared plus 2x plus 3 all on x. Now we look at this all on x here and you go, oh, we're going to have logs somewhere. Easiest thing that actually to do here is to separate it out into separate fractions. So we'll have 4x squared on x, which means the x will cancel, and we'll end up with 4x plus 2 plus 3 on x. So what I'm just going to do, just above here, I'll just show what's happened. So we've actually, intermediate step here is I have separated out the one big fraction into 3 smaller fractions and then simplified them from there. And now we just do each bit separately. So remember, when it doesn't have a power, it's a 1, so if we add 1, it will be 2. constant, you add the variable in, and now 3 on x, just like with the one above, we actually had that here in part F, we had the 3 on x, and we know the integral of that becomes 3 ln x, and then plus c, and then simplify. So we'll have 2x squared plus 2x plus 3 ln x plus c. And the last one, we want the integral of ln e to the 4t dt. Now the thing here to remember is the ln and then an e next to it, they cancel. So this just ends up being 4t dt. Ends up being really simple. Which means it's 4 on 2 t squared plus c. So 2 t squared plus c.